Welcome to Spring LIB.
Okay, we need to find the wavelength for a 28 giga electron volt electron. Wavelength is lambda for a 28 giga electron volt electrons. So how are we going to do this? A couple steps. We know that we can relate the wavelength to the momentum using the de Broglie wavelength formula. And to find this momentum, we can use equation 26.9 from the textbook. This relates energy squared to the energy from momentum squared plus the energy from the mass or the rest energy squared. So we're just going to solve this for momentum. Let's start first by writing this PC squared term on the left side and subtracting the MC squared term. So here we have PC squared equals E squared minus MC squared quantity squared. We could just take the square root of both of these sides. In this case, it's actually easier just to multiply this out. So you'll have PC times PC. This is simply P squared C squared equals E squared minus quantity MC squared squared. We can divide by the C squared term. And now we just need to take the square root of both sides. That'll cancel out this square term and leave us with this ugly thing. But it's okay because we can actually simplify this quite a bit. So the mass of an electron is actually quite small. It's on the order of 10 to the negative 31st kilograms. So with an electron that has very high energy, like 28 giga electron volts, we actually can ignore the rest energy because almost all of the energy is coming from the momentum. You can look at this and solve this with this term here if you'd like, but it actually doesn't change the answer at all. So we're just going to cancel that out, and we're left with square root E squared over C squared. And this simplifies to just E over C. So here is our final equation for momentum. Let's put that in blue and put a box around it. So all that we need to do from here is plug this into our original equation for the de Broglie wavelength. And I can rewrite that down here. That was lambda equals Planck's constant over momentum. And we know that momentum is E over C. So we're just, since this is in the denominator, we're just going to put the reciprocal in here. So we have H times C over E. And that's our final equation. Now, Planck's constant, just a constant, is 6.63 times 10 to the negative 34th joules times seconds. Speed of light is also a constant, 3.0 times 10 to the 8th meters per second. And our energy was given as 28 giga electron volts. We know that giga is 10 to the 9th. 28 times 10 to the 9th is the same as 2.8 times 10 to the 10th electron volts. So we can plug this in, but we're not quite done yet because we have electron volts here that'll go on the bottom of our equation, but we have joules on the top. So we need to convert electron volts to joules. And we can do that with this 1.6 times 10 to the negative 19th joules per electron volt. Multiply this by electron volts. The electron volts cancels, you're left with joules. So let's plug all of this in. Lambda equals 6.63 times 10 to the negative 34th joules times seconds times 3.0 times 10 to the 8th meters per second, all over 2.8 times 10 to the 10th, 0, electron volts times 1.6 times 10 to the negative 19th joules per electron volt. And all of this comes out to 4.4 times 10 to the negative 17 meters. We can confirm that this is indeed meters. We have joules here that cancel, electron volts here that cancels, seconds here that cancels. All that we're left with is this meter term. That's exactly what we want. So this is our final answer.